Welcome everyone to week 6 of our lockdown and the Wilcoxon signed rank test. Now hopefully by now you have handed in or submitted to me the either number 6, which you did last week or by Monday, or number 7 for the Wilcoxon rank sum test. I looked at everything you gave me, and it all looked great. I might have given you, a couple hints. The only, and I put those grades in eSchool. So if you look at eSchool and there is not a grade for fourth quarter, because this is the beginning of fourth quarter, that says Wilcoxon rank sum test, let me know if there's no grade there. I updated them this morning when I came in. Now the only difference, now if you recall, I'm just going to show you a quick little piece of number 7. This is just the back of it. I didn't do the whole thing. Now I had said, because the sample sizes were both the same, I said if you're in second period, the mid-size should be L1, sample 1. And if you're in fourth period, compact should be N1. It doesn't matter, because the sample sizes are the same, you can find the ranks of either one, because it said find the sum of the ranks of the smaller class size. And I think it's really cool that you will notice whether you do the positive, you add the ranks of the compact or the mid-size, you get the same test statistic. It's just that one is negative and one is positive. So you have your choice. Nobody's going to tell you if the sample sizes are the same, which ranks you add up. I add them both up, and I do them both. And if they both come out to be the same number with different signs, I know I'm right. Now, the Wilcoxon signed rank test, as you notice, we already did. This is the Wilcoxon rank sum test. That's what we did. That's what you gave to me, either number 6 or 7. That is for independent data. That's data. Compact cars are compact cars. They're not mid-size. You can't have a mid-size car that's also a compact. That's what independent means. They're two separate sets of data. The Wilcoxon signed rank test, which is WSRT, is for dependent data. This is before and after. This is comparing two different things. Or I should say comparing two of the same things. A pre-test, a post-test, before you drank some energy drink and after, and it measures the change in performance. Do not put all your data in one list, and do not sort the data, because we are looking at the same thing in two different cases. Now this is, this first one will compare the cost of a medicine. And it's going to compare the cost of medicine for an animal versus the exact same medicine for a human. And they want to know, HO of course is always the fact that the cost of the human dose and the animal dose are the same. So there's no difference. That's your HO. Again, there's no symbol here. Can't use muse, can't use, we used to use a little mu D for dependent, but we can't do that either here. You actually have to write it out in words. And this is the first time we've seen a one-tailed test with Wilcoxon. You can have a one-tailed test, we just actually haven't yet. So here it says, and you can write this two different ways. I wrote it as animal doses are less than human doses, or cost less. You could put human doses cost more than animal doses. It's up to you. And then here are, I just copied, here's the problem. And you'll get a copy of this. It says 8 drugs were selected. So these are the same drugs, A, B, C, D, E, whatever it went up, or up here, human dose, animal dose, same drug. This might be penicillin, this might be, whatever the drug is. And the prices for human dose and animal dose for the same amounts were compared. At alpha equals 0.05, can it be concluded that the prices for animal doses are significantly less? There's your fact that it's a one-tailed test than the price of a human dose. And then remember, at the end it says, if the null hypothesis is rejected and it appears as though animal doses do cost less, give one reason why the animal dose might cost less than the human dose. There's no right or wrong answer for this reason. It just has to make sense with what you did. So here's your data for human, here's your data for animals. These have to stay together because these are the prices for 8 separate drugs. So here's my column. Here's my human. Oh, I wrote on the back of a sheet of paper, so that's why. Right triangle trig, I think, is on the other side. But here's my human doses. Here's my animal doses. I put this in L1, I put this in L2, and I subtracted them. And you'll see that the difference is, it appears as though the human prices are higher than the animal doses because they're all positive except for this one. And a lot of them tend to be pretty big. So you take your differences and then you absolute value. So that 1.06 becomes a positive 6. And you will get a copy right here. Instead of giving you my note sheet, this is kind of more compact. Here is the procedure sheet that's in the book. And it kind of goes through everything we've done with the formulas and everything. And it may give you a little too much information. At the bottom, you do not need to use this formula. It just gives, that's just there for, it's like an added little note. You don't need that formula to find the critical value or the test statistic. I'll go through, it's all very easy. So we had our differences. Now, because this is a ranked test, you are going to have to rank something. There's not a lot of numbers, but the problem is you can't sort them in this column because we need to make sure that these ranks match with these numbers. So you just kind of have to eyeball, and I saw that this is the smallest number. You know, they're not that hard to rank. So you have 1 cent, 6 cents, 17 cents. The next biggest one is 20, 30, 40, 50, 78. So I rank them just by looking at them. You could put these in a list. You could sort them. You could rank them. But then these numbers have to be in this order. You can't, they don't want these rearranged. I want to know that this drug differs by 54 cents and this drug differs by 46. So there's your ranks. Then you're going to go back here and see which of those differences were positive and negative, and this is where the name of the test comes from, signed rank. So if you have a difference that's negative, that difference becomes a negative rank. You don't want to rank the differences because that means all the negative rank numbers would all be ranked low and all the positive would be ranked high. We want to rank them without difference, without it mattering whether it's positive or negative, so that this 6 cents lands where it's supposed to land. It doesn't land in a particular place. And it's not always going to be ranked 1 because it's negative. So you rank the absolute value of the differences, and then you add them up. Now, in this case, I added up some of the positive ranks, and I took, the only rank I have that's negative is 2. You're supposed to add the positive ranks, add the negative ranks. And the smaller of those two numbers is your test statistic. Now, you don't really have to add all these numbers up to see that 2 is going to be smaller than 34, but they will probably ask you somewhere in the question, if you take a test, if this is on the final exam, they're probably going to ask you to add these up, because many times you're going to have a couple negatives and a couple positives. This one was pretty basic, and there was only 1 negative, but that's your test statistic. Now, your critical value comes from a table. And it's a new table that we have not seen yet, and I'll show it to you in a second. It's going to need an N, and remember with dependent data, N is always the number of data pairs, and there were 8 different drugs they used. This is a one-tailed test, and they told us that alpha was 0.05. And this critical value I did wrong at first. It is 6. I changed it below. I didn't change it here. I'm looking for my pencil, which appears to have disappeared. So I'm just going to make this a 6. This is a 6. And you'll see in a second why I read the table wrong. So I'm going to look. Here is this new table, which, I will give you a copy of. Oh, just found my pencil. Here is, it's called Table K. Table K doesn't mean anything. It's just that the tables in this book are listed alphabetically. But it says critical values for the Wilcoxon signed rank test. We have 8 data pairs. We are one-tailed, and there's your 0.05. So if you go to 8 data values, 8 pairs of data, one-tailed, 0.05, there it is. There's your critical value, which is 6. And then it tells you right up here, reject the null hypothesis if the test value, which is the sum, is less than or equal to this, the value that's on this table, your critical value. So this means because the test statistic is so much smaller than the critical value, there aren't very many animal doses that cost more than human doses. If this is a big number, then half of them are probably more expensive, half of them are less expensive. When you add the big one, add the positives, add the negatives, you're going to get a big number. That means there really isn't a difference. Some are more expensive, some are less. But because the sum of these ranks is so small, smaller than or equal to this, it means we don't have very many animal doses that are more expensive than human doses. So we reject. Hey, speaking of animals, he's chewing on a candy wrapper. Support the claim, reject HO, and we are going to support the claim that animal doses cost significantly less than human doses. Now, my reason for this is, and I'm going to lift this up, and I'm going to show you, if this dog right here costs me a lot of money and I don't have health care for him, listen to me. Hey, Eli, look up here. See how he doesn't even listen? You're not getting any drugs if they're expensive because I don't have health insurance for you. There's his sad face. So anyways, there's my reason. Because there's no health care for animals, they can't charge, too much money because certain people, mean, horrible, rotten people like me, will not finance their dogs. He's a dog. When, he gets really sick, I'm not going to put thousands of dollars into drugs or surgery or anything for him. Okay, there's our Wilcoxon signed rank test. Today is Tuesday. By Friday, if you could, submit, I just did number 9 with you. If you could do number 10, please. Whoops. By Friday. We'll say the close of business Friday is 5 p.m. And let me just show you one more time. We did the animal doses. I think I just lost my page, but I'm going to find it. I'm there. I'm almost there. Here I am. I'm finding it. And here it is. Got it. You're going to do the property assessments for the different wards for 2006 to 2019 and see if it looks like, don't worry about the normally distributed, just I know this says use the sign test, but you are going to use, or wait, maybe we'll just do this one. 8. Okay. How about do 11? Because 11 is a signed rank test. So you are going to do the before and the after of weight loss through a diet. Number 11. Let me change that. That's not number 10. That's number 11. If you could just follow the procedure, it's Tuesday. Email me if you have any questions. eSchool is updated for 4th quarter. I'm not sure how they're going to grade 4th quarter. I have a meeting, I think later on, I may know a little bit more tomorrow or the next day. Third quarter grades, I think, should be up. So if you have any issues, shoot me an email. If you want to do a Google Meet, if you have questions or anything, let me know. Take care. We're almost through April. And by the time we finish April, I know we're out of school till at least May 15th. And by then, we should be done with course material. We'll have a week of review and then the final exam. And by Memorial Day, this course will be done. And then you can concentrate on, whatever other courses you may have. Okay, take care. Hope everybody's healthy. Stay home. See you soon.